All right, so
Yeah.
ever look up at the night sky, see the moon all big and bright, and think, how far away is that thing?
It's a question that's fascinated people for, well, pretty much forever, right?
Absolutely. And this time, we're diving into how someone figured that out over 2,000 years ago
Yeah.
without any of the fancy tech we have today.
No telescopes, no spaceships. It's hard to even imagine.
Right. Talk about a challenge. So let's jump in. We're dealing with a mathematician from ancient Greece, Aristarchus of Samos.
A real pioneer. His work is what we'd call thinking outside the box today, more like inventing the box when you really look at it.
Seriously. And we're working with two main sources here. One is a document titled O5 Aristarchus 01.pdf, and the other is this fascinating lecture, Greek Math Aristarchus Greek Math 01.4a.
Both focused on how this guy, Aristarchus, took on the challenge of measuring, well, the immeasurable.
Exactly. So no fancy equipment, just brain power and the tools of his time, which basically
I
means
guess.
you got it. All right, so where does he even start? How do you even begin to measure the distance to something as massive and as far away as the sun?
Well, the first thing to wrap your head around is that Aristarchus didn't just look for a ruler in the sky.
Okay, makes sense. So it's more about relationships between things.
Precisely. He was all about connecting the cosmic dots. And his big breakthrough, the moon.
The moon? Wait, you're saying he used the moon to figure out the distance to the SN?
Yep. It might sound crazy, but bear with me. It all starts with a simple observation. Have you ever noticed how during a full moon, it looks about half a degree across in the sky?
Half a degree. That's pretty tiny, like less than the width of my pinky finger if I hold it out at arm's length.
Exactly. But that tiny measurement was all Aristarchus needed. See, he knew a thing or two about right triangles, and he realized that if you think about it, the Earth, the moon, and an observer on Earth actually form a giant right triangle in space.
Okay, I can kind of visualize that. The Earth and the moon are like the two ends of the base of the triangle.
And the line of sight from the observer to the moon.
That's the right angle.
Yeah.
You got it.
And that's where that half-degree measurement comes in. It gives Aristarchus one of the angles in the triangle. Then, the distance from the Earth to the moon. Well, that's one side of the triangle. And the moon's radius.
That's the other side.
Exactly. And as you might remember from geometry class...
Oh, please, let's not relive those days.
Well, the point is, if you know one angle and the length of one side of a right triangle, you can use math to figure out all the other sides and angles.
Okay, so he's basically saying, figure out any one of these, and you unlock the rest.
Precisely. It's like a cosmic two-for-one deal.
I like the sound of that.
Yeah.
But there's a catch, isn't there? Like, how do you actually measure any of that back then?
Nah.
Especially the moon's radius. Are you kidding?
Now you're getting it. That's where Aristarchus's real genius comes in, and it involves, you guessed it, more triangles. This time with the half moon.
Wait, you mean like a crescent moon?
Close, but not exactly. Imagine the moon when it's exactly half lit, a perfect half circle in the sky.
Oh, right, I get it.
Okay.
Okay, so what's so special about the half moon?
Well, when the moon is exactly half full, it tells us that the positions of the sun, earth, and moon form another right triangle at that very moment.
Another one, with the moon at the right angle again.
You're on a roll. And here's the kicker. The angle at the top of this new triangle, the one formed by the lines connecting the Earth to the sun and the moon, that angle is directly related to the ratio between the Earth-Sun distance and the Earth-Moon distance.
Whoa, okay, hold on, let me get this straight. He's saying
that if he can figure out that one angle...
we can unlock the relationship between how far away the sun is compared to the moon.
You got it. He's weaving together this web of geometric connections, and it only gets more mind-blowing from here.
So this is all about finding those key connections, those relationships. Like, it's not just about measuring one thing in isolation, right?
Exactly. And, you mentioned eclipses earlier. Those play a huge role in Aristarchus's cosmic calculations.
Right. Okay, so remind me, how do those fit into all of this?
For Aristarchus, eclipses were like these gifts from the cosmos. They provided these moments of perfect alignment, these moments that gave him even more clues to work with.
Okay, I'm hooked. Lay it on me. What did he see?
Well, let's start with the total solar eclipse. You know that moment when the moon passes right in front of the sun?
Oh, yeah, it's like someone just flipped the off switch on the sun for a few minutes. Eerie. Amazing.
Definitely awe-inspiring. And for Aristarchus, this wasn't just a cool event. It sparked a huge new realization. He saw that during a total solar eclipse, you can actually think of the Earth, moon, and sun as simple shapes.
Wait, simple shapes. How do you simplify something as complex as like a solar eclipse.
Picture it this way. The moon and the sun. During an eclipse, they basically become two circles that are just about touching. And the Earth, where the observer is. That's like a line running right through that point where the circles almost touch.
Wow, so he's like taking this huge celestial event and boiling it down to its geometric essence. Pretty clever.
Exactly. And because he's already figured out that connection between the Earth-Sun distance and Earth-Moon distance,
Hmm.
well, he can use this eclipse model to figure out something else amazing.
What's that? Don't leave me hanging.
The ratio between the sun's radius and the moon's radius.
Hold on, hold on. He can actually compare the sizes of the sun and the moon just from watching an eclipse.
You got it. It's honestly what makes his work so revolutionary. But he didn't stop there. Oh no, Aristarchus wasn't done. Next, he turned his attention to the other type of eclipse.
You mean a lunar eclipse? That's when the Earth's shadow falls on the moon, right?
Right. And by carefully observing a lunar eclipse, he could actually work with something even more tangible. He could work with how many moons would fit side by side within the Earth's shadow.
Okay, now that is something people back then could actually wrap their heads around. No fancy equipment, just looking and counting.
And that's the beauty of it. From this seemingly simple observation, Aristarchus introduced this new value he called basically, it's the ratio of the moon's diameter to the width of Earth's shadow during a lunar eclipse.
Okay, so now we've got the Earth, the moon, the width of the Earth's shadow,
Yeah.
all connected somehow. Things are getting kind of complex.
But here's where it all comes together with these four observations: the full moon, the half moon, the solar eclipse, and the lunar eclipse. Aristarchus has managed to connect 5 unknowns, 5 mysteries of the cosmos, all linked together.
Let me take a stab at this.
Yeah.
We've got Earth-Sun distance, Earth-Moon distance, Sun's radius, Moon's
Yeah,
radius,
keep going. You're on a roll.
their Earth's radius. 5 unknowns, and they're all tangled up in this web of geometry he's created.
Yeah.
Like ancient Greek hacking of the cosmos.
That's a great way to put it. It really is. And you know the most mind-blowing part of it all Aristarchus needed to do was plug in actual values for 2 things he could really observe: the value from the lunar eclipse and the angle from that half-moon setup. With those 2 pieces of the puzzle, he could calculate the rest.
Okay, you've got to tell me, what does he come up with? What kind of numbers did Aristarchus get for all of this?
Get this, based on his calculations, he estimated the Earth-Moon distance to be about 40 times the diameter of the Earth.
40 Earths. I like it. It's a lot easier to imagine than some crazy long number, you know.
Good way to visualize it. And it gets even wilder. For the Earth-Sun distance, he arrived at a figure of roughly 724 times the diameter of Earth.
724 Earths. Wow. That's a pretty big number. So how'd he do? Was he close?
Well, we've come a long way since then. Today, with our modern instruments and all, we know the Earth-Moon distance is actually closer to 30 Earth diameter.
Oh, okay. So a little bit off there. What about the sun?
Even further. Turns out the Earth-Sun distance is more like 11,726 Earth diameter.
11,000. Okay, yeah, that's a tad different.
Mhm.
But still, to even try to figure this out back then
Mhm.
with basically no technology, it's incredible that he even got close.
Yeah, it speaks volumes about what you can achieve with observation, a bit of creativity, and a whole lot of geometry. And our sources point out that the inaccuracies in his calculations weren't really from, like, mistakes in his methods. The biggest issue was the limitations of what you could actually observe back then, you know?
Like with the naked eye.
Exactly.
Yeah.
Take that angle in the half-moon observation, for example. That's a tough one to get just right. We're talking about judging the precise moment when the moon is perfectly half full. Not an easy feat.
Yeah, I can see how that would be tricky. It's almost like trying to, I don't know, cut a pie into perfect, even slices in the dark.
Perfect analogy. So yeah, his measurements were definitely limited by the technology of his time. But the way he put it all together, you know, the way he connected those cosmic dots, that's what makes his work so important.
It really makes you appreciate how far we've come. Not just in terms of technology, but also in terms of how we understand our place in the universe.
Absolutely. Because remember, Aristarchus wasn't just measuring distances here. He was trying to understand humanity's place in the grand scheme of things. And he did it all without the tools that we take for granted today.
It's mind-blowing. Makes you look at the moon a little differently. It's not just this bright light in the sky. It's like this symbol of human curiosity, you know? This puzzle piece that helped us unlock some of the biggest mysteries out there.
Couldn't have said it better myself. And it begs the question, if Aristarchus could accomplish this much with so little, what does that mean for us? What incredible discoveries are still out there waiting to be made with the tools and knowledge we have today?
Now that is a question worth pondering. Looks like we've got some thinking to do. Thanks for diving in with us. Until next time.